Hello, my name is Scott Ellis, and I'm a product manager on Google Cloud. And today we're going to talk about managing sensitive data in hybrid environments. What we're going to cover today is a quick overview of our Cloud Data Loss Prevention, or DLP platform. And then we're going to go and see how we can use DLP in hybrid environments. And after that, we're going to show a demo of this by using DLP to inspect data in a MySQL database that's running in a virtual machine. And then we're going to migrate some of that data into BigQuery and use DLP again to do data masking or data redaction. Let's get started. So first, an overview of our data loss prevention platform. First, we feel that protecting sensitive data really begins with knowing where that data exists. And so one of the core features of our platform is discovery and classification. And our data loss prevention platform, again, is a fully managed service that helps you discover, classify, and protect your most sensitive data. And we do this, again, through discovery, classification, as well as a set of tools called de-identification, which is a way to transform or mask sensitive data. And this platform is built to work on structured data, unstructured data, as well as workloads that might be in real time or kind of at rest or in batch. To cover this in a little more detail, when we talk about discovery and classification of sensitive data, what we mean is being able to look at data and identify different elements inside that data that might be sensitive. An example of that could be things like personally identifiable information, or PII. This would be things like names, dates of birth, credit card numbers, and a variety of different things. And we have different types out of the box that we support that are both kind of global as well as country-specific identifiers. We also have some special categories like credentials and secrets that help look for things like passwords or auth tokens, whether it be on our cloud or other clouds. And these are things that might not identify a person, but are sensitive and might give a kind of a credential or access to privileged access to resources. You can also customize all of this either by defining your own info type detectors or by using detection rules to change how our detectors work or to tune them for your needs. That second set of capabilities, again, we call de-identification. It's often referred to as things like data masking or tokenization. And this is where we go in and actually manipulate the data to try to de-risk it or obfuscate it somehow. And as you can see in this kind of before and after animation, what we're doing is we're applying those techniques to different columns in this table. In the first three columns, we are applying a technique that basically transforms the entire column. And then in that fourth column, the comments field, we're actually using a combination of our inspection and our masking to look for data inside of the cell and only redact that item. So you see in that first row, we actually find an email address, but instead of removing the entire cell or the entire comment, we just remove the email address and leave the rest intact. So that's an example sort of how we combine our inspection and our de-identification to work on unstructured data or semi-structured data. And where this is may be applicable or where you might use this. One example is to help prevent exposure of raw secrets or sensitive data. So imagine, again, you had, let's say, your public website or your company website, and all of those public assets were hosted in a cloud storage bucket. And these are assets that power your website that are generally available to anyone when they're viewing your website. But what happens if somebody uploads something into that bucket or into that folder that is shouldn't be there? Maybe it's sensitive. So running something like an inspection scan of that bucket, we could identify, for example, here, if somebody uploaded a GCP credential into that bucket, which again, you would not want to expose that publicly, as it could give privileged access to some of your resources. Another example would be to kind of unblock workloads. Maybe it's a machine learning or artificial intelligence workload, or some sort of a cloud migration workload. And here we would look at moving data into those different environments and applying that de-identification to obscure or mask the data, but still allow that analysis or that machine learning to happen. Another use case would be really just to understand and classify data across your entire enterprise. And our cloud platform has an API, a REST or a gRPC API that enables you to call it from virtually anywhere. And that's what we're going to focus on in the next section, is how we can use this in hybrid environments that may be on or off cloud or on or off Google Cloud. And let's get into that. So what do we actually mean by hybrid environments? Well, really, we're thinking of, again, taking those core capabilities around inspection, classification, and masking, and applying it on data that might be in other clouds, might be on premise, could be in non-native storage systems. This could be like a database that you're running inside of a virtual machine. Maybe it's running inside of an application like a web or a mobile app, or it could, of course, be running on Google Cloud. So a few examples of that. Maybe you want to inspect data that's running in something like AWS's RDS system, or maybe it's a MySQL database running inside of a virtual machine, or again, a database that's running on premise. We're actually going to show a demo of this later, looking at MySQL running in a virtual machine. Maybe you want to inspect and tokenize data as you're migrating that data from on-prem into cloud, or between environments like production, development, and analytics. Another example could be inspecting and redacting transactions from a web or mobile application before you store that data at rest. So to do this, we're going to talk about two of our methods. These are two methods on our Cloud DLP platform, one called content methods and one called hybrid methods. Now, hybrid methods are a newer method that we've released recently, but let's go over both of these methods. So first, content methods. You'll notice actually that these are pretty similar as far as the kind of data sources that they apply to. This could be data running on any cloud, on-premise, and virtually any data source. But with content methods, it's what we call a synchronous like request and response. These are methods where you make a request, you send data in that request, and you get a response back in that request, and that response is sort of the answer. It's the classification or the mass data. These methods are stateless, and they allow both inspection and de-identification capabilities. Now, our new hybrid methods are similar, but a little bit different. What they do is they actually take your data, they allow you to sort of do a fire and forget, where you can send this data in for inspection, but then move on. You don't have to wait for the response or process the response. And here, DLP will aggregate that data and put it together and aggregate it so that you can store that data or analyze it, for example, in something like BigQuery, or make reports in Data Studio, or publish other types of alerts. And for now, this is only for inspection. And that's what we're going to talk a little bit about later and demo this later as well, how we can take information, send it through these hybrid methods, and then produce an audit report using BigQuery and Data Studio. But again, these are kind of the two methods you would use to handle data in hybrid environments. And here's an example of what that kind of audit report might look like. So again, imagine you're scanning data across several different assets, and you want to collect all of this in one place, analyze it using BigQuery, or visualize it in some sort of an audit report like we're showing here, using something like Data Studio. In this example, we're showing several different things that we've inspected. And as you see, we're getting results about what kind of database we looked at, what tables and columns and DLP findings we have there. Now, another aspect to this is what we call regionalization. And with DLP, you also have regional endpoints. And this means that you can actually specify where your data is being processed. So for example, let's say you want to inspect data from on-premise, but you want to make sure that the inspection part that's running on our platform is limited to a particular location. Maybe you want all your data to stay in Australia or in Europe or in the US. You can specify a regional endpoint, which means that your data will be processed in that region. And it gives you the control whether you're doing it for data residency purposes, or you're planning out sort of an availability or kind of a performance or latency requirement. You can pick those regional endpoints if you need to. Great. Now let's go in and kind of go a little bit deeper on what these hybrid methods look like. So when we use the new hybrid method, what we do is we create a hybrid job. And this job, it really is an active listener that's going to be listening for requests and then aggregating all those findings for you so that you can come back later and see the results. And when we define this request, we're going to basically create a job, and instead of specifying a storage location like cloud storage or BigQuery, we would pick a storage location of hybrid. We would then provide additional metadata for that job. Now, this metadata is important because that's the information that we're going to use to aggregate everything together. You can specify some of that in the actual job or in each request. And let's go into a little bit more detail of what a request might look like. So here is an actual code sample where we're showing what a hybrid inspection request would look like. On the right side, this is a code sample in Java. And what we're showing here at the top is there's some content that we want to inspect. In this case, we're going to be inspecting tabular data. So we provided headers and rows of that data. Then we have our actual hybrid request. In this case, that's where we're supplying all of those details, all that metadata that we want to aggregate around. So here's where we would pass it things like a MySQL database type or a version or maybe a database name or table name, because we want to add those kind of things to our report later on. And then we send the request. And in this example, again, this is just showing the snippet that will basically provide all that information and send that request in. And then on the server side, DLP will inspect that data, aggregate it together, and allow you to then go in and analyze that information using something like BigQuery or Data Studio. Great. Now that we've shown you kind of what a request looks like, let's move into an actual demo of this. And what we're going to show in this demo is we're going to scan data that's running in a MySQL database that is running on a virtual machine. We're going to inspect that data, and then we're going to migrate one of those tables over to BigQuery using DLP again to do masking. So we basically can kind of protect that data as we're migrating it from this virtual machine into a managed service like BigQuery. Great, let's get started on the demo. We're going to show a demo in two parts. Part one, we're going to inspect data from a MySQL database that's running in a virtual machine. And to do this, we're going to use a custom script that's going to read this information, send it into our cloud data loss prevention platform using the hybrid inspection method, which is going to then write data into BigQuery, and we're going to visualize that in Data Studio. The second part, we're going to migrate a table from that MySQL database using Cloud DLP and Dataflow to tokenize that data as we move it into BigQuery and migrate it from MySQL into BigQuery. Let's get started. Great. The first thing we're going to do is create a new hybrid job. To do that, I've navigated to security and then data loss prevention in the Cloud Console. And now I'm going to click on create and then job. Provide a name for the job and then pick a storage location of hybrid. Now, hybrid again means that it's going to create an active listener that's going to be listening for request streams. Each of those request streams will include the content that we want to inspect, as well as any labels that act as metadata. So again, these labels could define the type of data that we're scanning, maybe a database. In our demo, it will be a MySQL database, the database name, and the table name. Now, we can put required labels here, which means every request is required to have that label filled out, as well as optional labels that we can apply at the job level, but that can be overridden by each request. Now, the rest of this job configuration is similar to other job types. I define the types of things that I want to look for, either by using a template or by putting the configuration as I have here in the job. And then when I'm done, I simply click create. Great, now that we have our job, we're ready to use it. So I switched environments here to a project that is running our MySQL VM. Now, in this case, we've chosen to use Google's Compute Engine to host the MySQL instance and run the script. But again, this could be a VM running, anywhere, either clouds, on-premise. And again, the script here that we're running is connecting to the database using a standard JDBC protocol. And so we're in the VM. Let's go ahead and just see what kind of data we have here. So what I'm doing here is I'm just simply selecting a database called Company2, and then we are seeing the tables that are in there. It looks like we've got a handful of tables, and we're going to use DLP to inspect these tables. Now, in the job, we've configured it to write and save findings into BigQuery. And so that allows us to then go do analysis either in BigQuery using SQL or in a tool like Data Studio where we can visualize things. Great, let's get started. So we're going to run a script here. Now this script again is just going to look at the information, stream a sample. In this case, we've set the limit to 10,000 rows per table. It's going to stream a sample of that data. DLP is going to inspect it and then generate those findings. I'll also note here that even though we have a username and a password in this command line, that's not the actual database password. we are using our secret manager, which is a tool that allows you to protect enterprise and production secrets in instances like this. So as you see, we're running this script here, and you see that little note here, retrieving password from Cloud Secret Manager. And we're running this script, and in just a few seconds, we've gone through all the different tables, read a sample, and done some inspection here. And again, we named this Next 2020 Demo 1. So when we go into our report, let's look for that data. So I'm going to switch over here to Data Studio. Now, this is a report we've been using for a lot of test runs. So we already have data in here. And now we've run test runs on local instances, one's running in Compute Engine, one's running in different systems from other clouds here, as well as even running against systems like BigQuery, which also have a JDBC connector. So again, it's a very versatile script. And again, leveraging our hybrid methods, we're able to see all of this data from several different runs, all collected in this audit report. But I'm going to go ahead and refresh the data here. And let's see if our demo data is available yet. So again, we sent those sample data into DLP. It inspected it. Now we're just kind of refreshing to see if that data is available. Okay, so we see here we have Next 2020 Demo 1. Let's click there and see if we can see any findings here. It looks like we found 90,000 different things. Again, sending 10,000 rows per table, there could be multiple findings per row, so that's probably where we got into the 90,000. Great. So we see a couple different tables here, and we're going to look at this first one, the cars table. Again, as we see here, it looks like we were running MySQL version here. Again, we scanned database company 2. It looks like we found something in the cars table. We found a VIN number and an email address. So again, this is just a quick way to show the power of hybrid. So what we did is we ran the script, streamed in a sample of data, and within a few seconds, we scanned all the tables. And a few seconds later, that data was inspected by DLP and made available through BigQuery and Data Studio for reporting. Now, again, for part 2, we're going to actually take some of that data from that database and migrate it into BigQuery and use Cloud DLP to tokenize that data along the way. So if you remember, we're going to use this cars table here. And if you remember, we found sensitive data, VIN number, and email address. So what we're going to do is we're actually going to migrate that data. So we're going to export it from MySQL, and we're going to use a pipeline that is powered by Dataflow in order to process that data and ingest it into BigQuery. Now, one of the first things that we were going to do, though, is define exactly what we want to de-identify. So to do that, we're going to navigate back over to our security and data loss prevention in the Cloud Console, and we're going to create a de-identification template. So I click here on Create, go to Template. We're going to do a de-identification template. Now, de-identification is a term that's really to a collection of techniques to transform this data. And in this case, we're going to do a record transformation. And let's just call this test DID 2. Continue here. Now, when we're doing a record transformation, what that means is that we're going to apply transformations on an entire column. Now, we can leverage our info type inspection as well. And that's the thing that we use to find that VIN number and find that email. But in this case, we've already done that. If you remember, we had a column called VIN and email that had sensitive data in it. So we're just going to create a simple template here. For the field VIN and email, we're going to do what's called a primitive transformation. So we're not going to rely on it finding the email in the VIN because we already know that column has it. And we're going to simply go in and we're going to do a deterministic token or pseudonymization. What that's going to do is convert the VIN and the email into a token that keeps deterministic and referential integrity. Now I'm going to cancel this because I've already created that template that we're going to use, which is listed here as Next 2020 Cars DID 1. Now I'm going to navigate over to Dataflow. Now in Dataflow, we've actually already got this pipeline running, but just to show you how we got there, we'll click on Create Job from Template. We name our job. This will be Test Job 1. And we actually pick an existing template here called masking tokenization from Cloud DLP to BigQuery. This is going to ask us for a few parameters. Again, it wants to know the path that we're going to land or drop our CSV files into. Where do we want to ingest them in BigQuery? And again, that reference to that de-identification template that we just created. So again, filling this out, clicking Run Job, that's how we get this pipeline started. But let's actually go and show this pipeline in action. So I've got this pipeline running here. And I've also got the bucket that I'm using to ingest this data. Now, we already downloaded or pulled that data out of MySQL. And so just for the purpose of this demo, what I'm going to do is go ahead and upload that file. Great. So we just uploaded a very small sample of this file. Again, we're trying to show sort of that end-to-end workflow here. So as we see here, it's pulling for the input file. It looks like we processed some files here. We've run some tokenization. I'm going to go over to BigQuery here. Let's just refresh this so we can pull up that data set that we're writing the results to. And let's see if it's there yet. Okay, great. So you see here we have a cars table that's just been created. Let's just go look at a preview here. And as you can see, the email address and the VIN number have both been obfuscated and basically de-identified so that we're protecting that information. What this means is someone can now analyze this data that we've extracted and moved over from that MySQL database without revealing the email address. But they can still do joins, they can still do aggregates because we've chosen to use a deterministic tokenization method that preserves that integrity. So again, the same email gets the same token, same VIN number gets the same token, but we're not revealing the underlying sensitive data. And this concludes the second part of our demo, where we wanted to show sort of a hybrid migration, taking data from a hybrid system, in this case MySQL, and migrating that into cloud, in this case into BigQuery, using Cloud DLP to protect that data through tokenization and de-identification. Thanks again for your time. Great. Well, I hope that demo showed you some of the power of Cloud DLP and how you can use that in hybrid environments. For more details, check out the link below where you can learn about our data loss prevention platform, as well as see more examples and use cases for how to apply DLP both on cloud and off cloud in these hybrid environments. Thank you again.